Hello, you're about to watch a video of a bench test of my electric motorcycle equipment, which is all set up and ready to go, just not yet integrated onto the motorcycle. What I've got here, I'll go through component by component. I've got a test switch box, which is simulating the key switch, which is on the left, and the run switch of the motorcycle. I've got a couple of lights on here, which are going to indicate when the 12-volt system is active, and the green one, which will indicate when the drive system is active. What should happen is we should first turn on the key switch, and what that'll do is turn on the switched 12 volt in the DC to DC converter. And that converter is embedded in the charger, and through these connectors right here, that switched voltage will come on, and the red light should come on, which really means that the motorcycle lights and horn are operable. And also that means that we can go to the next step and turn on the run switch. When the run switch comes on, what we expect to see is the green light will come on, and we'll apply 12 volts to the relay. The relay has a 12 volt coil, and that will close those contacts, which are rated for the full pack voltage. And what that'll do is several things. It'll turn on the controller. We should see the green light come on the controller, and we also ought to see the cycle analyst power itself up. And that's going to tell us all the information that we need about energy usage and so forth. And most importantly, the contactor is going to close. The contactor has a 72 volt coil and contacts that are rated for the full current and voltage that the battery and motor are capable of flowing. So let's go ahead and start it up. First, the key switch is turned on, and you see that the red light is on. That indicates that indeed the 12 volt system is active. After that, we'll turn on the run switch, and we see the green light is on. That's good. That means that we have current flowing through our relay. You probably also heard the sound of the relays closing, both the small one and the contactor. And hopefully the motor or the controller is powered up, and we see the green LED light is in fact on. And if we look at the cycle analyst, we see that it is powered up and telling us all the information we need about our battery state and consumption. And we've got 88.6 volts, almost a full pack. And so the last thing to do is to turn the throttle, which is going to apply the right amount of power to the motor via the controller. So let's go ahead and try that. Okay, I'm going to rotate the throttle, and you can probably see and hear the motor has started to turn. As I increase the throttle, the motor turns faster and faster, up to a maximum of 3,000 RPM, and it looks like things are working pretty well. And when I release the throttle, it smoothly slows back down to a standstill. So great bench test of the system. No problems are evident at this time. Now we'll go ahead and shut it down. We'll do that probably by first turning off the run switch. That is going to turn off the drive system and controller and cycle analyst. And then we'll turn off the key and take the key out of the bike. When we do that, there's a 5-second delay until the switched 12 volt is disabled. And then nothing is enabled on the bike. So we're not drawing any power except for a tiny amount that's used for the unswitched 12 volts coming from the DC to DC converter. Now let's take a look at the bike that it's going to go on. This is a 2005 Royal Enfield, the military version, the Bullet 500. The motor was blown last year, so all the internal combustion engine components are stripped off, and it's ready to be turned into an electric. The motor will go right where the transmission was. The batteries will go where the motor used to be, and the controller will probably go up under the seat or inside the tank, which is hollowed out. Haven't figured out exactly where it'll go. Inside these little boxes here, we'll probably put some of the electrical components that we want to keep out of the rain, and we've also got some metal panniers, one of which will contain the charger and the integrated DC-DC converter. So it will have an onboard charger and DC-DC converter, and there'll be no need for a 12 volt battery just to run the lights and other 12 volt system. So it should be nice. You notice though that there's some work to be done on the frame here. When the motor was removed, that breaks the frame, and so I've got some work to do there. cutting some custom metal in a way that will both restore the strength to the frame and also provide a place to mount the batteries to. So I've got a lot of challenges ahead of me, but this is a nice little preview. Thank you. Bye.